All right, so I want to spend some time talking about what sort of bonds these elements actually can make. And we can predict a lot of these bonds as well. So just a quick review from our class. We had said that lithium, its Lewis structure had one electron here. And then we also probably talked about chlorine, which had a Lewis structure that looked like this. The reason why it had that Lewis structure was, remember that you have 7 valence electrons here. And for this one, you only have 1 valence electron. Okay? And if the two of these join, you have a total of 8 valence electrons. So let me just define some of these things. We know that lithium is a metal and chlorine is a non-metal. And if these two come together, here is my lithium with its 1 electron, and I'm going to put it here for right now and you'll see why. Chlorine, remember, has 7, 1, 2, 3, 4, 5, 6, and here is 7, okay? So that means that chlorine has a total of 8 electrons, so it's pretty content. It has had as many electrons as it wants. And the reason it has 8 electrons is because lithium actually gave it an electron. So let me change my color to, let's see, in color to black. So lithium's original electron was here, and it actually gave its electron to chlorine. So that means that lithium that just gave its electron is going to have what sort of charge, would you guess? More positive. And chlorine has a negative charge. And these two are attracted to each other because of charges, because we know positive and negative charges attract. All right? So these two will actually stay together and based on purely their charges. And it's because in this situation, lithium gives its electron to chlorine. All right, when you have a metal and a non-metal coming together where they give electrons, one gives an electron and one takes it, we call those ionic bonds. All right, so it always has to be a metal with a non-metal. So this is a classic ionic bond. It is giving its electron to, the lithium is giving its electron to chlorine. And we always show that with arrows, all right? So let's do another one. I'm going to have you actually try it out. We have sodium. And we'll have, how about fluorine? All right? First thing I want you to do is identify which ones are the metals and the non-metals. So here we have the metal, and here we have the non-metal. Again, sodium has just 1 electron. Fluorine, on the other hand, I'll use a different color, has 7 electrons. All right? What's going to happen is sodium is going to give its electron to fluorine. And now you have sodium with fluorine together. That is its chemical formula. Those are ionic bonds. So now let's work on a different type of bond. And this bond would be perhaps, let's say we have hydrogen. All right, that's H. And we know that hydrogen is a non-metal. So just keep that in mind. Even though that it's on the left-hand side of the periodic table, it is a non-metal. And we have also chlorine. Chlorine, Cl, is a non-metal. So let's do our Lewis structures on here. We'll do chlorine to have 7 electrons, like we said before. And hydrogen, we'll use a different color, we'll go for orange, has 1 electron. So it's a little bit different. In ionic bonds, we had metals with nonmetals, but now with 2 nonmetals, what happens instead is that the hydrogen wants to have a total of 2 electrons. So why do I say that? Well, if you look at your periodic table, you'll see that hydrogen has only 1 electron in its shell, meaning it only has 1 shell. It wants to have 2. That makes a complete shell. Chlorine, on the other hand, wants to have 8 electrons. And so what they will do instead is that they will share their electrons. So it is not giving its electrons. Hydrogen is not giving its electrons to chlorine. Instead, they share electrons. And the way we show that graphically is that we create, we'll use purple, circles. So here we have hydrogen. It wants 2 electrons, and in fact, it has 2 electrons. Chlorine, on the other hand, wants 8 electrons, and it gets 8 electrons. So this is a bond that forms. One of the things that you may have noticed when I was doing all of these, that whenever you have a substance, let's say, for example, oxygen. Oxygen has a Lewis structure that looks like this. It has 6 electrons in its valence shell. That means that it has a binding site here because it just has that 1 electron, and it has a binding site here. So let's use an example. If we had 2 hydrogens that were going to bond, so that allows us to have oxygen bind with 2 hydrogens. And we'll have oxygen be red. Hydrogen be red. All right, same story. Here, 2 hydrogens that have 2 electrons. They're happy. And this oxygen, on the other hand, has 8 electrons. So it's happy. When you have non-metal combining with a non-metal, it is called a covalent bond. And that takes care of it.